Okay, so we just looked at some of the strategies that people used to get the various win conditions, and now we had a question about how one of them worked, and the method that Seth used looked at each of those win conditions one at a time. So he started with the most rare and then went to the most common in order. So he started off with lucky sevens and tested, changed this math right here to test for lucky sevens, and basically you had to add another equals equals, and you put actually hard coded 7 in those values, and then he would basically duplicate this each time for each one of what he was testing, but instead of each segment of that test, first he's testing for this, then he's testing for that, and then he's testing for that, will be triggered by the calculation of the previous thing. So this one is first triggered by the game over, right? The next one down the line, instead of being triggered by the game over, where this game over is getting passed into each of those integer boxes, instead of that, it would be the calculation of the previous step would trigger those integer boxes to evaluate the next step in the process.
If the math involved was heavier lifting, is there an advantage to doing it in that sort of waterfall way?
Yeah, cascading, I think is the word you're looking for.
Cascading, all right.
Yeah, I mean, computers do math really well, and for doing these sorts of just basic number math, there's really not many calculations that you could throw at it that it's going to slow it down. You really don't start getting into problems doing math operations until you're doing math operations on every single pixel of a video stream or something like that.
Like video-wise, if it was like there's all these different conditions.
Right. Yeah. So there's certainly more and less optimized ways of doing math on video streams, and that's a specific subject that we're going to be going into. Yeah. If you are doing math on a per pixel basis, it can really slow things down. There are other ways to do things using what are called shaders and OpenGL optimized math operations that will be less of a lift. But we'll get into that later in the semester. But yeah, these general kind of just working with number boxes and just doing math, you can do almost anything, and it's not going to slow down your computer. That being said, certain types of numbers are faster than others. Certain types of numbers use more memory than others. So wherever you can optimize your code, it's better. Like if you don't need to use floating point values, integers move a lot faster through the computer system than 32-bit or 64-bit floating point values. So yeah, if you're just doing simple numbers between 0 and 255, you can represent that in 8 bits, whereas if it has to be a floating point, it might be 32 bits. So that's a huge difference. Okay, so let's look at the method that I did. So yeah, we started off with this little segment of code, which just tests whether everything is the same. And I think I showed you right at the end how we could use this to test for all sevens. Basically adding a 7 here. And there'd have to be 3 of these, because we're having to test whether every single one is a 7. And 2 of these plus objects. And then instead of selecting for 2, we select for 3. Right, and so that would tell us whether we won with lucky 7s. Let's here, in order for some real estate, first of all, let's take your patch and save it as class 4.1. Whoops. I'm going to call mine 4.1b because I already have a 4.1. And let's grab all of this, all of your win condition stuff, darn it, and encapsulate it into a subpatch. Which, remember, is Shift-Command-E. And just call that win conditions. Make sure you're not using any space. Now we have this nice whole canvas to work with for just our win conditions. All right. So what I did was I had all of these calculations going on at the same time, and each one of set it up so that each one would output its value or its point score, and then we just selected we just added those point scores together, and if it was greater than, if it was 0, if you had a point score of 0, then it would automatically say you lose, and if you had a greater than 1, it would say you won. And if you got the jackpot, it would tell you got the jackpot. So here's the way I did it. So started off with these integer boxes. I don't need these down here. You zoom in? Sure. And these would also trigger all of these. Is that right? Yes. Actually, I didn't even do that. You don't even need more than one set of these number boxes. So put all of this in the middle and send this into these as well. And don't need these yet. Actually, I'm not even going to need these in this subpatch at all. Okay, so that's for all the same. This is for lucky 7s. I can't type today. All right, lucky 7s, and then again, I think some of you guys figured this out. To do a ascending, we just have to add 1. We can either add 1 to both. Stop scrolling. Add 1 to both of the middle ones, or we can add 1 to one and subtract 1 to the other, which is what I ended up doing. So let's see. It's just like this. But before you're testing whether they're equal, you add a +1 over here. Whoops, and I just did what Trey did. Forgot to put my space in there. And you subtract 1 over here. And so this wheels comes in there, and it adds 1 to it. This one, the middle one, stays the same. Nothing happens to it. And this one, we subtract 1. And then, the middle one stays the same. And then that one, we subtract 1. So that brings everything to the middle number. I think some of you did it the other way, where you brought everything up to the upper number. Doesn't matter. Either way is the same. So that is, so we're adding 1 down here. That means it's an ascending condition. And then same, duplicate that. But swap these to be -1 here and +1 there. And this would be the descending condition. Let me move this out of the way. Okay. There. All right, let me clean this up real quick. So what I try to do when I'm doing this sort of thing is pick a level that each one of these wheels will have its patch cord at, and then stay consistent with that. So I'm putting the first wheel all the way up at the top, and the middle one in the middle, and the third wheel at the bottom. Gets a little confusing. There we go. Get out of there. Another thing you can do that is kind of helpful for this sort of thing is to do some color coding of your patch cords. So you can use the Option key, hold down the Option key and drag. Oh, I missed one. Hold on. And select, that will select patch cords. And then I can go over here and go to Object Color and make it have its own color. And then slide over that one, Object Color. And Object Color. And so now I can easily see what's going where. There. Okay, so now what I can do is have each one of these, choose a point value for each one of these, and then add those points together, and then we can not only determine whether we won or not, but how much we won, based on what is more valuable, or what is more rare. Okay, so what is the most rare thing here? Obviously, that's lucky sevens. So I said that lucky sevens should be worth 500 points or $500. So what I did was over here I put a 500 because if it stop scrolling. It's this stupid magic mouse. It drives me crazy sometimes. If this gets a 3, then it will send out a bang, and I can use that to bang out this 500. If it doesn't get a 3, it will send out whatever number it has over here. What I'm going to do with that is convert that to a trigger and trigger 0, because I don't want it to send out some partial value of only being half right. I only want it to send it out if it's right, and if it's wrong, it'll send out a 0. So that right there, that triggering 0, that solves the issue of being half right on two different things and having those conditions add up to being completely right, which we don't want that to happen. And then same with over here. Let's say the next rarest. What's the next rarest?
Equals.
Yes, all the same, right? So that one I said equals 100. And a trigger 0 if it's not true. And then for each of these, I just did 50 on the ascending and descending because they're equally rare. Then I did a little expression where I added all of these together. You could do 4 plus objects if you really wanted to, but I just felt like doing an expression, and I thought that was a good example for you all. Expression. So there's specific syntax. Again, $I1 is the first integer, plus $I2 is the second one, plus $I3, the third one, plus $I4. So those are, whoops, no space, and I need to have a space in between the plus. There. So now it will have all of those different inputs, and it will add those together. So this is the first one, and make sure you also send the 0 in there. 50 and 0, right? Because if you don't send the 0 in there, then it will, if you won once before, it will always have that second value be a 50 until it gets replaced. So you need to make sure to replace that with a 0 if it's a loser. 50 and 0 and 500 and 0. Okay, and then now that we've added all those together, let's send it out an outlet. Outlet. Great. Now you can close that, and here's your win conditions. Now your win conditions have this outlet, and you can pass that into a message box or a number box or something. So go ahead and add the little thing to test your patch by add a bang over here and send it into the game over. Send as a workaround so we can cheat. And go ahead and set your wheels to, let's start with lucky 7. Set them to 777. And then bang the game over. And you can see it gave me 600. Now, why did it give me 600? It should have given me 500. Anybody know why it gave me 600?
Because you did all the same at 100, so we just added it.
That's right, because look, if you look at the X's here, what ended up being true? Both of the lucky 7 ended up being true and the all the same, because all 7s is all the same. So if we want this value to give us 500 when we get lucky 7s, all we have to do is just put this to 400 because we know it's going to add 100 over here as well. So I'm saving that. Now let's try it again. Just hit that bang again, and now it's giving me 500. And if let's just test the ascending condition. 6, 7, 8 gives me 50. So there, that's working great. Now all we have to do is put something on there that just says tests whether we won or not. Like greater than 0, right? Well, let's go ahead and make sure that non-win condition works. Like just change this to something else. And good. Okay, it is sending out a 0. Great. So now let's just put a greater than object and greater than 0. And then select 1. Right? So if it's greater than 1, that means you won. I mean, if it's greater than 0, that means you won, and that will come out here. So we can send that out to the game win. Whoops, send game win. And that will put that message of you're a winner in there. And then if it's less than 1, if it's 0 or less, it will come out here as the loser. And so then we just need to put, I believe, oh, right, send that into a button so that it converts whatever number that is into a bang. Because we're using message boxes up here, and if you send a number into that, like a 0, it's going to replace that message with the 0. So we need to convert that 0 into a bang, and you can either use a trigger bang TB, or you can just send it through a button. That will do the same thing. And then send from that button, send that to game lose, right? Because if it's 0, then obviously they didn't win. And so now let's test this again, which I already have my game condition set to lose. And it populates that up there with try again. And if I change this to win, winner. Okay. One other thing we can do, we can, actually not inside this. We can do another select over here. Do a special winner message for the jackpot and select 500. And so if it gets a specific $500 value, then it's going to send jackpot. And then up here we can receive the jackpot message and change this message to jackpot. So now, if we get 777, why isn't it working? What? Why didn't that work? Well, it probably, let me see what's coming out. No, it's definitely sending a bang. Why doesn't that work? That should work. Set jackpot. You try with
The order operations thing?
you know what? Maybe. Oh, I think you're right. Yeah, it is an order of operations thing. It's because it's putting the winner first. Because the set winner is lower down. I bet you that's it. If I move this message like down here, it might work. Let's try it again. No, maybe not. Darn it. Let me try moving it over here. Let's see if that does anything. Or maybe that receive has to be lower. No. That's a mystery to me. Let's see. What did I end up doing? Huh.
Shouldn't your text be in parentheses?
My text be in parentheses.
Like jackpot.
No, not in parentheses.
Oh,
maybe
not-
quotation marks if there was a space
sorry,
in it.
That's what I meant.
But there's no space in it, so it shouldn't matter, but I can try it. Yeah, and I just don't know why that's not, when it's sending a bank, it should send a bank. I think it is getting replaced by this winner for whatever reason. This is coming in second.
What if you break the cord on the winner? Does it work then?
What I need to do actually is do this. I could do it this way. So I go through this select object first, and if it's a 500, it automatically goes out to the jackpot. And if it's not, then it sends it to this calculation to see whether you won or not. That should fix it. Let me try it again. Yeah. That's a workaround. It definitely was some order of operations problem somewhere, but I couldn't figure out where it was. So I explicitly got around it.
Jackson?
Yeah.
My win conditions patch doesn't have any outlets, and my sets are yellow and don't work.
Yeah, I don't have an outlet either.
So did you put an outlet? You need to type an outlet after this. Add an outlet object.
I think I can use that.
Yeah.
Well,
Type
I
outlet.
should just talk to you about my patch.
Okay.
Do you know why my sets are yellow?
No. Let me see. Where are your sets yellow?
Right
Oh. Because those are objects and not messages. They need to be messages. It doesn't know what a set object is. Okay. There's one other method of doing this that's really similar to this that I wanted to show you. And basically, you just structure each one of these things so that they always get a different outcome. Let me just, actually, I don't want to build this with you, but it will be in the class patch. Let me just show you it really quick on the website. Here it is. So this is one other method, which is using expressions. But you see, we redid how this all the same is done. Normally, all the same, you don't need 3 equals objects, right? Because of the transitive property. If A is equal to B and B is equal to C, then obviously C is equal to A. But we added this third equals, which is comparing C and A. just so that it has a unique result that's different from everything else. And then we did this, we extended that one thing even further for lucky sevens. A equals B, B equals C, C equals A, and C equals 7. So that will equal 4 when you add them together. So these both equal 2, this equals 3, that equals 4. And then down here, we feed that into a single select object that's testing for each of those outcomes, 2, 3, and 4. And then you could set those same point values down here, where small being a 50, big being 100, and huge being 100 or 500 or something. And then loses whatever. If it's not any of those, then it's a loss. So that was one further way you could do it. All right, where am I? Okay, let me look at my notes. All right, so we need to do next. We need to do the money function, right? So let's see. Yeah. Okay. So here's what I came up with that. So this system gives you. Right, so that's the amount of money that comes out there, and I could just put that on a display and saying you won 500, but that's not that exciting. We like to see in a slot machine scenario, we like to see the money racking up, right? Right, that's way more exciting than just saying 500. So what I ended up doing is using a metro object to increment the counter and then stopping that metro when it gets to the amount that you were supposed to win for that point value. So the first thing I did is have a metro, whoops, not a message, new metro, and 40 millisecond interval I found made a nice fast count up without being too fast. And send that, let's see, I'm going to need a toggle to be able to turn that on. And then send that into a counter object to actually do the counting. Right? And so what we need to do is we need to set what number this counter is going to count to. And we need it to count, basically we need it to count up to whatever that point value is for the win condition. So we can send this win condition into the counter's maximum value, set counts maximum, which is the very last inlet on the right. And let's see. Okay. And then we can also, all we have to do to actually turn this metro on is send this value into this toggle. Because a toggle will turn off if it gets a 0, and it will turn on if it gets any non-zero number above, any number above 0. So automatically, if we win something, this toggle will turn on. If we don't win anything, it will turn off. And then we need to set a system to, when we get to the maximum, turn off that toggle that's driving that counter, right? So on this counter, there is counter hit maximum flag. We can send that to the toggle, but I think what it does is it sends a 1 when you hit that. So we don't want to send a 1 because that would trigger the toggle. I mean, that would turn the toggle on if it wasn't on already, and if it was on, it would just continue to be on. So we need to trigger a 0. Whoops, not a toggle. A new object T0. And now we're going to send that 0 up here to turn off the Metro. And then let's, for right now, put a int, a number box down here. Shortcut is I, so that we can see that come through. And then set your dials to lucky sevens and hit the button. And you can see it's counting up now. And it should stop when it gets to 500. Three, four, and maybe I should have done not lucky sevens. 500, and it stops. And let's just test that out for the ascending condition. 6, 7, and 8. Send. Oh, didn't work that time. But if I do it again, it does. So there's also some order of operations problems on this going on. So what I want to do is explicitly set the order of that number coming out of the win conditions so that I get things to the right place at the right time. So I can do trigger I. That will give me 3 separate events of 3 separate instances of the value coming out of this. And now I can explicitly set what I'm going to do with each one of these as they come out. So this is the first one that comes out, order output 1. And I'm going to use that to set the maximum counter on the maximum count on that counter. So that gets set first. Then the next integer is going to turn on the toggle. And then the final one is going to be evaluated for a win. So that should solve it by explicitly setting what that order is going to be. And yet it doesn't. Darn it, why? Well, there's one other thing that could be happening. This counter could be on some wrong value. And wait, why didn't it? It's probably that the counter was not getting incremented right. What we really need to do is when we first, whatever number the counter is currently on, so say the counter got shut off before it got reset, before it rolled over. So it hit its maximum flag, it's shut off, but it's still on 49, or it's still on 50. It's not on 0, ready to start to count to 1. The next bang we do sets it to 0. The next bang sets it to 1. And so now it's behind, and that can cause some problems with things getting hit in the right order. So let's add something to this trigger. Let's add a 1 to reset it to 1 when it first went, before anything else happens. So put a trigger in between the very last I and, yeah.
Okay, so it's TII 1I.
Yeah, exactly. And then take this and move it over 1, because that should be in the very last outlet. And then take this 1, which is the second thing that's going to come out, and it will reset and send it to the second to last inlet, which says resets to that number immediately. So the first thing that's going to happen is it sends the maximum count to the maximum count of the integer. The second thing that happens is it resets that to 1. The third thing that happens is it outputs to this toggle to turn it on. And then the last thing that happens is it gets sent out to the game win-lose analysis. And actually, let me just move this over to make that more clear. This should be over on this side. Great. All right, let's try that again. So I'm going to start with a losing condition. And that's right. It said I lost, right? Let's try again. It put a 1 down here because we told it to reset to 1. But that isn't the one that we're evaluating, right? We're evaluating what gets passed from here, which is a 0, which has ended up sending that game lose. That 1 is actually just for counting purposes. It doesn't actually equate to anything. And now if I set it to 6, 7, 8, it's counting correctly. And it does that. And because I won, it played that coin sound that I had set up. All right, so that's cool. Let's see. There's one other thing we need to do. And that is, I'd like this coin thing to loop. Because I'd like it to be making coin sounds as long as it's spitting out coins. And then when it stops spitting out coins, then we stop that coin sound. So we need to add that system to stop the coin sound. And and also we need to create a system for keeping track of how much money you have and not letting you play if you haven't put any money in. So and those aren't as complicated as they sound. It's actually fairly simple. So because we already have this is the difficult part that we already have this whole counting system. So in order to keep track of how much money we have, and in order to make that number count up and down, there's an object called IncDec, which stands for increment decrement. So it's a really old object, but it's still really useful. IncDec. And it gives you a little symbol of this plus up and down arrow. That's the IncDec. And we're going to use this to store the money. So this counter automatically turns off this metro when it gets to its maximum value. We actually don't even need to display this value anymore. And we're not going to actually use that counter to do the money. We're going to use this IncDec to do the money. The counter there is just so that it starts counting and shuts off when it gets to the right value. So in order to get IncDec to increment or decrement, we have to send it the message inc or dec, right? If you right-click on any object on this inlet, it will show you a list of attributes and messages that object takes. And as you can see, inc will make it go up and dec will make it go down. If you send it an int, then it will set that value and output it. Or you can send it a set value message, and it will set it with that value. So message inc. So every time this metro bangs, we want it to increment that counter. Yeah, and then send that into an integer down here, and that will be actually displaying what you have. So let's test that out really quick. 6, 7, 8, I still have on my counters. Hit go, and you can see it's incrementing that, and it's counting up, and stops. It stopped at 49. Oh, I set this to loop, so it's going to keep playing. So I got to figure out how to get. We haven't added the system to make that stop yet. Let me turn off the loop for now. So you can see, like, I had 49. Now I have 98. So there's kind of a bug there. It shouldn't. It should go all the way to 50 and not 49. So I have to try to figure out what happened there. It might have been that. Let me see. Message set 0. We're going to need this anyway to make sure that when you first turn this on, it's going to clear everything in there. Let me test it one more time. It's still going to 49. Yes, darn it. Well, instead of setting this counter to 0, let's set it to 0, and maybe that will fix it. Because then it will give us maybe one more count before it turns off, and then it will get to 50. Let's try it one more time. Set 0, and test that. And now it gets to 50. Okay, so that worked. When I did this earlier today, I had it on 0, and it kept doing 49, or it kept doing 51, and I had to make it 1. But for whatever reason, I had to. It's probably some slight order of operations discrepancy that's causing that.
Where did you do that?
Where did I add a? Right here on this trigger.
Yeah.
Change the 1 to a 0. Now it should be 50 down here when you win. Okay, so now we need to, so that can be, so let's add this to presentation. Whoops, it's Command-Shift-P. And it should put a little pink border around it. Whoops, too far. Right. And go into your presentation view and move that somewhere where you can see it up here. I'm gonna probably, you know what's best on this on the message box go into your inspector and change the justification to center, and then stretch the box all the way to the entire width of whatever your panel is for that. And then it will always be in the center of that panel, no matter how long it is, how long the message is. All right, so, okay, so that will be the bank. Let me adjust this a little bit. I'm gonna make that triangle invisible. So the triangle color here, I'm gonna grab that and draw the opacity down to 0. You can also just say don't draw the triangle up here, draw triangle 0, but then it will move that 50 over to the side, and I actually want that space because I'm going to put a $sign there. And I'm going to put bank, colon, space, $sign. And put this up here like that. And I think I'm going to change the background color of this to be something more pleasant than dark gray. And then I'm going to change the text color to be more readable. There we go. So now I got that. We need to create the system that won't let us play if we don't have any money, and we need to be able to add money if we don't have any money. So in order to do that, let's see here. Let's add this bank gate. Do a new patcher P bank gate. Should open that up. We're going to want an inlet on this. And inside there, where the hell is my bank gate? Did I not get this in my notes? I guess I didn't. All right, hold on. Okay, it's pretty easy. We need this stuff in there. So in there, there's a few things that's going on. First thing is when we hit that play button, right? That bang is going to come in here, and I'm taking that bang and sending it to 2 bangs, triggering 2 bangs so that I can do a few things. The first thing I need to do is check whether I have any money. So have this go to 2 bangs. This bang gets sent out to a send that I call bank check. All right. And then receive that bank check over here by your ink deck. And come on, I thought I had this in my notes. Yeah, okay, here it is. So a bang to the bank check will send out whatever, a bang to the ink deck will send out whatever is currently in the ink deck, right? So receive bank check. That's that bang. It's going to come out here, and that's going to get sent back to the bank gate. Okay, we'll need to receive that in our bank gate subpatch. Close that, we don't need that anymore. Where did my bank gate, there it is. So then we receive that bank gate there, and then at that point we decide whether or not it's greater than 0. Right, so if we had 0, then we're basically not going to let the that button's impulse go through. I created a gate 2 because I wanted to do. I could just say a gate and not let the button info pass, and that would work. It would not let you click it if you had 0, but it wouldn't tell you that you had 0, and so you might just keep clicking, thinking that something's broken. So instead, I'm having it send that to, if it is less than if this is greater, if it's greater than 0, we'll send a 1, and then I'm adding 1 to that. If I get, so that means if it is a 0, then the value will be 1. If it's greater than 0, then the value will be 2. When you send a 1 to a gate that has 2 outlets, it opens up the first outlet. If you send a 2 to a gate that has 2 outlets, it opens up the second outlet. So when I'm sending that 1 for not having any money, which is really just a 0 that I'm adding 1 to, then it sends out to this send broke, right? If it has money, it's greater than 0, it adds 1, then you get 2, and it sends it out this outlet to go to pass on. It sends out the outlet of the subpatch, and it also sends to this what I'm calling bank debit, which is just getting sent to one of those deck messages down by the ink deck that subtracts $1, so that every time you hit go, you're paying your $1 to play. Does that make sense? You guys all have this? Okay. So then down here we need to add receive bank debit, I think is what I called it, right? And send that to a deck message, and that gets fed into the ink deck. And then in order so that when we first load this ink deck has nothing in it, add what's called a load bang. And the load bang, as soon as you open the patch, will send a bang out this, which then I'm sending to the set 0 and making sure that that has nothing in it when you first turn it on. So now that's great. Everything should work. Oh, so let's test that really quick. Click on the set 0. So that should, and also send this set 0 to the actual number box down here. That way, when you're testing it out or whatever, or when you save it and you open it again, that this number box starts with no money in it. Then now we can test whether our bank gate works. So I don't even think we've hooked it up yet. So we have to hook it up first. This needs to go into there. And this needs to go into there. And so now it should let us not play. Yeah, nothing's working, right? It's not telling me anything because I haven't set that up yet. What did I say? Broke. So I said if it goes out this, it gets sent to broke. And then broke comes over, needs to come over here to the message center. Receive broke. And we can have that send the message, please add money. So now if I try to do this, it should make that message say, please add money, and it does. So that's almost everything. The last thing is we just have to have the ability to add money. And that's a really simple system. So let's go into presentation mode. This will make this easier. We still have all this set up. That's good. In this mode, we're going to... no, I'm sorry. Don't go into presentation mode. Just out of presentation mode. So in order to add money, we basically need to send the appropriate number of ink commands to that ink deck to get it to the whatever money you wanted to add to it. So I have a int box, then that's how much money we want to send, and that gets fed to what's called an Uzi object. Uzi, it's a great name. Why is it called an Uzi? Well, it's whatever you tell it, whatever the argument is, that's how many bangs it sends out in rapid succession on the other end. So if you say Uzi 100, it's going to send out 100 bangs like an Uzi. Right? So we can just pass this into this right inlet, which if you hover over that says how many bangs to shoot, and then have a button that goes onto this, start shooting the bangs. And then if you hover over this, out of the bottom, stop scrolling. It says, watch out, because that's the business end of the Uzi. And just send that to an ink message. And then you can send that ink to a send object, like send to, what did I say? Send to bank. And then receive the bank over here. And just send that straight in. And so now, now go ahead and add these two to presentation. Shift Command P. Go into presentation mode. Put them up here somewhere. Actually, I'm going to put my button on that side. And I'm going to add a comment. And commit. So now I can say add $500, commit, and now I have $500 in the bank, and I can play. There was one other thing that I had mentioned. Oh my God, it's 2:30 already. Jesus. All right. This just takes too long. One other thing I mentioned, that was the looping coin sound. All we have to do on that is where this counter triggers 0, we need to send that up to stop this sound from playing, right? Because when it triggers 0, that's going to stop this metro. We can also have that 0 stop the coin sound. So let's add a send over here, send, and call it coin stop. And then receive coin stop up here. Goes in there, and then on this coin on this coin sound effect, set it to loop, and then drag some portion in the middle to set a looping region on that. And now let's test it out. Oh, here, let me add that. So that kind of works, but it would take us forever to randomly win. So let me add this little testing button to presentation, and I'll just put it over here. So another thing you can do is when you have things in presentation, but you still want to be able to have access to things that you don't want a normal user to see in presentation mode, you can just like put them over on the side, and then you can actually set up your patch to only show this, and you'd have to be able to scroll over to see something else. But I'll go more into how to do that later. That's kind of a more advanced thing. But for right now I can use this button to test this out. Let's set it up for lucky sevens, because that's the one that's going to loop the longest. And test it out. Oh, it's not working. Why? Should have worked. Darn it. Why did that not work? Let me try it again.
Jackson, where should receive coin stop be? Or what should it be connected to?
It should be connected to the playlist over here that has the coins.
Gotcha.
Why didn't that work? That should work. Darn it. Why? Does your guys do the same thing where it doesn't send the sound? Is it working for anybody else? Or it's not sending, is it not sending the sound? Son of a gun. I don't know. All right, I'm out of time for this thing. I got to move on. So that's whatever. The sound's not working right. There's something weird about it. I'll have to look at it, try to figure out what's wrong. I don't know. Set 0. That should freaking work. I don't understand. It's the game win. Wait, okay. I guess I need to make sure what's coming out the game win. Oh, I know why. And why it didn't work on the last one. It's because we're intercepting this jackpot, and that's what I was testing with. We're intercepting this jackpot and not letting it send game to game win, right? And game win is what's triggering this coin thing over here. So what I need to do is also have jackpot trigger the coin thing over here. So receive jackpot and also send that the 1. So the jackpot makes the sound, and the game win also makes the sound. That's why. All right, let me try it again. Yes. And it should turn itself off when it gets to the amount. Still counting. Jesus, what happened there? No. Why is it not stopping? There, it did. It did. It just took a long time. There, yeah. It's because it's the jackpot, right? I wanted it to take that long because you want to feel really excited about how much money you won. All right, so that works. And there's a better version of this with comments and stuff that's going to be on the website. So update your patches, get them to work with all these different things, and then turn them in again. But please turn in the version that you have right now, your class 3 version, not the one we just did. Turn that in, email me that, please. And then email what we just did with any improvements that you might have for next class. Let's go back to Jitter now. Finally, new patcher. Actually, open up your class 3.2 file. This was the only thing we had a chance to look at last class. And basically, we were looking at how a matrix works, right? And the matrix is used you can use it for anything, but it's most often used to describe a video frame, a single frame of video. And then you have matrices that are changing over time that's giving you live action video or full frame video. So this is a really simple matrix that's basically of resolution 4 pixels by 3 pixels. And the first 2 values are the coordinates of the matrix. So like, and it counts from 0 up. And it counts also in Jitter and in OpenGL in general. When you're talking about the y-axis, 0 is at the top of the screen. Normally, you would think that 0, 0 would be at the bottom left-hand corner, but in fact, 0, 0 is at the top left-hand corner. So positive x values go to the right, and and positive y values go down. So if I wanted to put a white pixel, and also the values, it depends on what you have set on what kind of matrix it is, but if it's a char, it means it's an 8-bit value, which is a range of numbers between 0 and 255. So 255 would be white, and 0 would be black, and half gray would be 127. So if I wanted a white pixel in the upper left-hand corner, what value would I have to put in this set cell message or pack object? 1, 1, 255. All right, let's try it. 1, 1, and 255. Bang here, and then bang here. It's not quite it's not in the upper right-hand corner. Why do you think that is?
0.
Exactly, because we count from 0. So this time let's try 0, 0, 255. Bang and bang. There it is.
I got something different.
You got something different.
Yeah.
When you put 0, 1, 1, 255, it goes in the upper right-hand corner?
No, I did 1, 1, 255 and the same thing happened, but then I changed it to 0, 0, 255, bang, bang, and I got an L shape.
Okay, you have 3 pixels.
Yeah.
So you banged more than once, or you banged in between. Here, let's automate this second bang so we don't have to do it. There's a shortcut to do that, and that's do a trigger in between this pack. So go pack, bang, or I'm sorry, TBL. L is short for list, right? Because it's a list of values, and that's what the pack object creates. It creates what's called a list, right? That's the list it created. The words set, cell, 0, 0, then val, then the value 255. It's a 1, 2, 3, 4, 5 item list, right? So that's the L here. So the first thing is it's going to send out that list to the matrix, and then it will follow that with a bang automatically, so we don't have to do it in between. So now if we go to what would it be to put a pixel in the lower right-hand corner on a matrix that is 4 pixels wide by 3 pixels deep?
3, 2.
Yeah, 3, 2, right? Because it's one less than you'd think because it's counting from 0. 3, 2, 255, bang, and it's there. If we wanted to clear all of these, go ahead and right-click on this little inlet right here. Unlock your patcher and right-click on the inlet of the matrix, and that, again, will give you a list of attributes and messages to that object. You can use the word clear. Oh, and that's, I forgot, this is a new Mac 7 thing. You can, in that list, when you right-click on it, if you click on one of those messages, it'll automatically give you that message with a variable after it, like set cell variable and clear $1. That $1 is a variable, and all you have to do is put an integer box in there, and that will replace that $1 with a 0. But actually, we don't want to clear. That would be clearing a specific a cell, and we want to clear everything. I think the thing is just clear all. Is it? Nah, let me check on that. It might be set all. Hold on.
Jackson, I'm sorry, what's the bottom object called? I kind of had to go back to the phone.
Set all.
The J.P. Okay.
Yeah, set all. Sorry. Yeah, that's a P window. Jit.p window. Set all $1, and now you can put an integer box, connect that, and now you can. Oh, but you'll have to bang it again. Do a comma after this and bang. There we go. Now you can see I can set all of those values as something between, and you could, so now if I set all of them as 0, then you'll have it back to black. Okay?
I'm sorry, can you zoom in?
not
Thank you.
Yeah.
You need glasses.
there we go.
Does that work? So
Still
play
works.
around with that. What would so if I wanted a gray pixel, a half gray pixel in the middle, what would I do on any of the middle type pixel? Any of the middle type. There's a couple different spaces that could be considered in the middle, but just give me any of them.
2, 1.
2, 1, 175. Yeah, great. That's exactly right. Cool. Let's move on to colors. So that is what's called. This is what's called a one-plane matrix, and you can tell that based on the arguments here. The 1 refers to that it has one plane. The char refers to what type of values it stores. In this case, 8-bit integers. And then 4 and 3 are its dimensions. So let's create another matrix that is a 4-plane matrix, because that's what you need for color, right? You need A, alpha, R, G, and B, red, green, and blue, and the alpha channel.
Hey Jackson, can I ask one question?
Yeah.
I'm trying to figure out the need for the bang, because when I change my ints, it just automatically does everything.
When you change your ints where?
When I change like
Up here?
Yeah, when I change the position and the intensity, it just automatically updates the.
This?
Yes, if I change that, yeah. See, if I do that, it just automatically.
Did you use a POC instead of a PAC?
P-A-K.
Change it to P-A-C-K.
Oh, well, that's.
So a POC will send out its message if any of the values of that message, of that POC are changed. A PAC will only send it out if the first value is changed or you send a bang into it.
Gotcha.
And because the first value is the word set cell, we're never changing that. That's why we have this bang here to send that out. If you use a POC, it's going to automatically send it out.
That makes complete sense.
And then over here, we use the comma here to separate this out into a second message. So first it sets all to whatever, and then it sends out a bang. The comma in messages, comma will denote a separate second message. So great, we're going to do a new kind of matrix, jit.matrix for char 4, 3. Okay, and actually, let's just copy this, duplicate that, and instead of actually on this, change this pop to set the val, because we actually need 4 values. Change that val 0 to val 0, 0, 0, 0. And yeah, and now add some value, add some integer number boxes. Whoops. And make sure you're skipping that number. Sorry, make sure that these are in the very last 3. Oh, I know what's wrong. I need a 4th one. There we go. It's like things are not lining up. Make sure you're skipping this element 4 because we don't want to replace the word val. We still need that word in there. Okay, and then send that into the JIT matrix. Duplicate this P window, bring it over here. And so what would you think? Here's another thing I wanted to show you guys. There's another object called an attrui, A-T-T-R-U-I, attrui, and that stands for attribute UI or attribute user interface. You can connect that to an object to get its various attributes. Connect it to the matrix object, and then you can go down here and choose something like dimensions. That will show you what the dimensions are for that matrix or whatever that object is. You can get all its different type of info. See, it has 4 planes. Its dimensions are 4 by 3, etc. So that's that. Okay, so attrui. ATTR, Ils should start filling it in for you. ATTR. Okay, we have 15 minutes. I think that's just enough time to do this and then go into the movie player. Okay, so if I wanted a red square in this upper left-hand corner, what values do you think I would send? First, the coordinates.
0, 0.
Right? And now what value do you think red would be on char values? First one is alpha.
Second.
So first one is alpha. So what is we want a fully opaque pixel.
So 255.
255. The second one is red. So what would that be?
255.
Full red, 255. Second's green, third is green, and the fourth is blue. So 0, 0. Bang, and then we have to take this trigger bang list thing and bring it over here. And bang this again. There we go, red pixel. And so what if I wanted a cyan pixel in the lower right-hand corner?
3, 2,
255, 255, 0, 255. What he said.
3,
bravo.
2, 255, 0, 255, 255. Bang, cyan pixel. Great. So that's that. And you guys can play around with that till you know what a matrix is. And I think you guys already do at this point. Let's look at movie players. So, movie players used to be completely in the realm of QuickTime. Yours didn't work? All right, let's. Whose doesn't work?
Oh, it's out of the second
You
thing?
forgot the list. You have to connect the list because it never sent your list. Sorry, that TBL has a second outlet
Oh,
on it.
he's gonna tell. Yeah, this one is.
But unlock your path
That's
matrix.
not lit.
And there you go. That should fix that. Anybody else is not working?
Mine.
I need to try mine again.
Where's your Jit dot? That's what I
You
mean.
never
Yeah,
connected
yeah,
your
add it.
bang?
I did. Wait,
Where
I
is
don't
it?
have this.
Oh, it has to go to
Yeah,
both?
another one. The P
Just
one.
like
I
over
switched.
here.
Oh, I missed that.
So you're sending your list, but you're never banging
Jit
that
dot,
matrix.
Jit.
Escape.
No, Jit.
Send it out of the outlet of the bang.
Out of here.
Yeah, sorry. Yeah, out of the trigger bang list.
Oh, so it needs both.
Yeah.
Oh.
Oh.
That trigger bang list right here.
Alright. Yeah.
Right here, both of these outlets need to get passed into the JIT dot matrix.
So that
Okay.
that should move up here. Nobody.
All right. So this object up until now used to be called JIT.QT.movie because it used to use, not QT, but QT as in QuickTime, because it used to use the QuickTime codec or API. But now it has a new one, and it can use the QuickTime if you tell it to be QT. But by default, it just uses its standard one, which could use different codecs, which QuickTime is kind of old, and there's some new ones that have new APIs for playing video that have come out that will give you way better frame rate at high-res videos. Like AV Foundation is the main one that Max uses. So Max uses AV Foundation unless you tell it to use QuickTime, and it's better to use AV Foundation. So if you pull up some really old help stuff, you might see jit.qt.movie, but they generally will work interchangeably. But jit.movie. Okay. Now, jit.movie, basically you're reading a movie file into it, and it has its own metro in there that generates these matrices for the image coming out the other end. But we have to tell it to read a file first. Message read. Send that into the movie. And we also need to, okay, actually let's start with that. And get another P window. Send it down there. Hit read. Now find a file. All the media for your thing, it's a little bit difficult to get into. It's actually embedded in the application in Max 7. So go over to your applications. Actually, here, close that open window and open a Finder window. You won't be able to do this with that open window. Go to Applications and go to your Max, find your Max application, Max 7 application, There it is. Right click on it and say show package contents. That shows this hidden file structure of that application. Then you can go into contents, Mac OS, no, that's not it. Resources, yes. Resources, C74, media. And in fact, just to save time in the future, grab this media. So it's under C74, under resources, under contents. Drag that over to your favorites over here so that you have a shortcut to that. And then you won't have to expand that package content, show package contents every single time. So then you should have it over here in your favorites, and then you can go to here and you can click on Jitter, and then all the movies and videos that come with it are right there. So now go to read, back in the application, go to read, and now you can use that shortcut to get to that. Go to Jitter, and let's start by reading countdown.move. Okay, you won't see anything because the jit.movie won't output a frame until it gets a bang. Send a bang into it, and it outputs a frame. Click on that again, and you can see, look, it's a 10. Just click on that in rapid succession, and you see an animation, right? Right? But stop clicking on it for a second or 2 seconds and click it again. And now you look, it's a 2, not a 7. So time is still going on in this movie, even if it is not outputting frames. That's something really important to remember. That it doesn't just send out the next frame when you hit bang. It sends out whatever the current frame that it's on its internal clock. If you need its internal clock to stop, you actually have to send it a stop command.
So is that processing that video?
What?
Like, is that actually processing? Like,
Yeah,
if you put like 20 of those in there, would it really bog down your computer?
Yes. So it is taking this video and it is converting, it's reading that file and converting it into a series of matrices that's outputting that the outlet, and that's why you have a green line. And yes, that is not necessarily the most efficient way to do videos. If you're just playing videos, there is a way of loading, and this is new to Mac 7, there's a way of loading your video as a texture and sending it to the OpenGL world as a texture instead of a series of matrices, and that is a lot faster, but that's something we'll get into later in the semester. For right now, we're going to work with matrices, and yes, they are not the most optimized way of doing things, but it's the best for learning what's going on.
I didn't catch what you clicked to load the video.
Read is to load a video, and then go, if you were following along with me, go to your media in your favorites and then choose something in the Jitter folder. Actually choose countdown. So then, yeah, you can see that. So it's got its own clock. If I send it a stop command, now its internal clock has stopped, and it'll still output the last frame that it was on, but that frame is not advancing.
To keep it going, would you do like a metro with a toggle? Or
So if we wanted to actually see all of the frames that it is outputting, we would do a metro, right? And so that we're banging automatically, and we don't have to click that bang 30 times a second to get full frame video. So metro, and what would give us, say this is a 30 frames a second, what would give us 30 frames, 30 FPS? What milliseconds for the metro's argument? 33. Not exactly, but close enough. And then a toggle.
Still like first year.
All right, so now this is sending out bangs. We hit stop, so the movie's not actually going, but go ahead and hit start. And now you're getting full frame video, more or less. Right? Now, there is a thing, now video will sometimes drop frames. And when you have this metro sometimes when it drops frames, if you have what the regular metro, it causes problems. If you want this to be a different kind of metro called a Q metro. And then if it drops frames, it will just continue on where it left off, and that handles any system lag better. It's a little difficult to explain what the difference between Q metro and metro is. Read the help file. Just put a Q. Just my advice is just always use Q metro. You really don't need a regular metro unless you're dealing. If you're using video, use Q metro. If you're just using a metro to make some other objects do some things, you could probably use either. But
Q metro more processor.
So this is exactly. It's not. No, it's not. It's what it's doing is.
That's alright. You don't have to explain it. I was
It's a metro.
help file, Jackson.
It's a metro with a jit.q ball after it. It's basically those two different things put together.
Spoken when they're naming this stuff. I love it though.
That a Q metro is basically these two objects together. What is a jit.q ball? Converts messages at a scheduled time to a low priority, right? Yeah, it's kind of hard to explain. But if you go into if you read the reference file for Q metro, it tells you why. Yeah. So, there's one other thing I wanted to show you. Get time. Oh, all one word, actually. You can send that into a movie object. So say we stop this metro. It's not outputting frames, but the movie is still advancing. Click this get time, and you can see what frames are going on there.
Get, G-E-T.
Get time, all one word.
Is that the timer object?
What?
Is that the timer object?
That's the time. No, that will tell you what the timer, the internal timer of the jit.movie is on right now. There's another, so there's various different attributes you can do with jit.movie. Another one that is that's useful a lot of times is at unique one. And what that does is, say you're banging out 30 frames a second, but your movie file is only a 15 FPS file. You're sending the same frame out twice. And if you're doing operations on that frame, you're sending it through some filters or whatever. Now you're using twice the amount of processor because you're doing that operation twice when you didn't need to. You only needed to do it once because the frame is the same as the last frame. So this at unique one will only send out movies frames when they're different from the previous frame. So add a read message over here and read I think a good one is track 1. That's a 15 FPS file, track1.move. And do another JIT-P window and send your Q metro in there and there's one other thing. What is it? JIT.FPS GUI. JIT.FPS GUI. And then send that out there to tell me what my frames per second are. And do the same thing actually over here to this one so you can see the difference. Start that up. And why am I not getting, I'm getting 0 frames per second. Oh, I guess you do it on the first outlet, not the second outlet. Yeah. And actually right click on this, stop it. Right click right here and go to click on, where is it? Unique. Where is unique? Unique. Right? And so now uncheck unique. God, my optimization is really bad. What's going on? Oh, it's because I'm screen recording. That's why my frame rate is super, super low. It's because I'm screen recording. But you can see, look, so it's doing 30 frames per second, and when I activate the unique, it drops it down to its actual file frame rate of 15 frames per second, but it's going really shitty because I'm screen recording. That probably won't be an issue next week when I have my new laptop that has solid state, and every